Hello students, good morning. Today you are going to learn a new chapter which is the core of the physics. We can say these topics are core part of the physics, that is electrodynamics. So this is the core part of the physics, and here it consists of totally 3 chapters. Important chapter, moving charges and magnetism. Sometimes it is also called magnetic effects of electric current. Because another name, some textbook they say magnetic effect of electric current, and second one electromagnetic induction. After that alternating current and AC circuits till electromagnetic waves. Okay. So this is generally we call it as the electrodynamics. Okay. So let us start today the first important chapter of the electrodynamics, that is moving charges and magnetism. So moving charges and magnetism. So moving charges and magnetism. Moving charges and magnetism. Moving charges and magnetism. So as I told you, some others they will say this is the magnetic effects of electric current. Magnetic effects of electric current. Okay. Another name. Some others they will say it as magnetic effects of electric current. Okay. Right. So here why I say this topic is very important, because of course all chapters are important, there is no doubt in that, because our examination point of view, every chapter we are going to get definitely one or two bits. That is not important here. But these electrodynamics is said to be very important, because here the concepts are somewhat modern concepts. All of them are modern concepts. Okay. So here this electrodynamics is based on 3 fundamental concepts. Number 1, we know already, when a charge is at rest, it produces electric field. That we know already. A charge at rest. Charge at rest. Charge at rest. First one. Charge at rest. Charge at rest. Produce only electric field. Only electric field. Only electric field. Very important here. Only electric field. When we take a charge or a charged body, it produces only electric field. Next, charge moving uniformly. Uniformly moving charge. Charge moving uniformly. Charge moving uniformly. Charge moving uniformly. Moving uniformly. Moving means in motion, that is uniform motion. Uniform motion. Uniform motion. Uniform motion means you know already. Uniform motion means what? Velocity is constant, both magnitude and direction, because velocity is a vector. So both magnitude of velocity and direction of velocity remains constant. then we say it is uniform motion. Therefore, a charge in uniform motion produce electric and magnetic fields, both electric and magnetic fields. Magnetic field, electric and magnetic field, right? So when a charge is in motion, it produces both electric and magnetic fields, right? Next, third concept. Third concept here, that is the third concept that we are going to discuss here is, now let us take a charge accelerating, accelerating charge, So accelerating charge not only produce electric field, magnetic field, but also radiate energy. So produce electric and magnetic field. Not only produce that, not only it produce electric and magnetic field, but also radiate energy. It's very, very important. Whenever a charged particle is accelerate, that not only produce electric field, but magnetic field, but also it radiate energy. Continuously it is going to radiate energy. So these are the three concepts on which the complete electrodynamics has been built up. So first one, a charge at rest produce only electric field. A charge in uniform motion produce electric as well as magnetic field, and an accelerating charge not only produce electric field and magnetic field, but also radiate energy. So that is the three concepts on which this electrodynamic is based on, right? Now, before 19th century, that is till we can say mid of 1800, 1820, 1830, that is we say the beginning of 19th century, scientists have a opinion that there is no relation between electric field and magnetic properties. Electric property is a different entity and magnetic property is a different entity. There is no relation between electric and magnetic effects. Means no relation between electric and magnetic fields. Okay, that is they are entirely different. So a Danish physicist named by Ørsted, Johan Christian Ørsted, a professor at the University of Copenhagen, Denmark, he wanted to demonstrate in his class that there is no relation between electric field and magnetic fields, no relation between electric effect and magnetic effect. So for that, he is conducting one small experiment to prove there is no relation between those two quantities. They are entirely different entities of a physical object. So for that, that generally popularly we call it as the Ørsted experiment. That is said to be as the Ørsted experiment. So let us see what is this simple arrangement